Hello everyone, it's a great pleasure for me to share with you some information on the potential effect of abiotic factors on grapevine and berry physiology and development. This talk has been prepared with my colleagues Dr. Suzy Rogiers from Australia and Anne Pellegrino from France. So during this talk, I'm going to address some questions. For example, are climatic variabilities between years a nightmare for vineyard management and wine production? I suppose the answer is already yes. I'm going to speak about the effect of abiotic factors, mainly about water, but as well light and temperature on vine physiology and berry growth and composition. And then at the end, we will share some take-home messages. Speaking about wine business, wine production, as you see with this figure, it's about volume and obviously it's about price as well. So speaking about volume, you need water. You need water in the vineyard to manage the yield. Speaking about what we call the terroir, which is the interaction between soil and climate, as you know, water is a very important parameter, but not only. Temperature, light, wind, air humidity are as well crucial. And did you know that to produce, from a vineyard point of view, a bottle of wine, 250 to 350 liters of waters are needed? This figure is showing the annual rainfall variability between vintages from 1980 to 2008 in the south of France. And you see that the annual variability of rainfall is around 300 to more than 1,000 millimeters a year. So I guess the climatic variability between years in terms of heat waves, in terms of rainfalls, certainly are one of the most important aspects of climate change. And this is really impacting on vineyard management and wine styles, and on a yearly basis. But it's not only about water, it's about light, sunlight, and it's about temperatures as well. And this slide is showing many years of research on the potential effect of light and temperature on berry growth and composition. I really don't have time to develop, but you will have access to the presentation and you might want to have a look at those results. To summarize, I will say that for some compounds, light and temperature will stimulate their accumulation. For other compounds, light and temperature will decrease or will have no effect on their biosynthesis or accumulation. So, berry development and ripening, it's not only about the potential variability between vintages, it's as well a day and night story. In fact, researchers did show that some genes involved in berry composition are mainly and only expressed during the night. A few words now on the effect of vine water status on yield components. The rule of 70-30 will be presented. Grapevine yield components, it's a 2 years story. And the climatic conditions and vine physiology will impact year 1 and year 2 on yield components. So, from year 1, in terms of differentiation of primordia of inflorescences in the latent buds, up to year 2, up to berry set year 2, these are the 70% of the yield component. From berry set to harvest, the 30% represent the berry number per clusters and the volume of the berries. Let's see now how vine water status will affect vegetative growth and how this is helping to shape the vine architecture, obviously according to the training system which is used. The width of the canopy is due to the growth of the laterals, the secondary shoots, and the growth of the secondary shoots is under the control of vine water and nitrogen status. This study from Lebon et al., published in 2006, clearly did show that the rate of leaf appearance of the primary shoots is under the control of vine water status in relationship with soil water availability. So the rate of leaf appearance of primary shoots is affected, starts to be affected when the soil water availability is around 35%. If you remember, I told you that the width of the canopy is due to the growth of the secondary shoots. And this study from Lebon et al. Did show that the secondary shoots laterals are more sensitive to vine water status than the primary shoots. So the rate of leaf emergence in and for the secondary shoots starts to be affected when soil water availability is around 55%. This figure is showing the vine water status thresholds measured using the pre-dawn leaf water potential. And the thresholds are going from no water constraints to moderate water constraints and water stress. While moderate water constraints could be positive for vine functioning, reducing the vigor of the canopy, water stress has to be avoided at all costs, because then it will impact on the sustainability of a vineyard. So what to do in terms of vineyard management for wine regions or vineyards for which there is little water, available water? Knowing that 98% of the water, the needed water for a vine is transpired, the first step will be obviously to reduce the leaf area per vine. And because the leaf area per vine is reduced, the yield per vine has to be reduced as well to respect the ratio leaf to yield. Another tool we do have in the toolbox is obviously as well to reduce the plantation density, the number of vines per hectare, and to use small training systems instead of big training systems. This can be done up to the point from where the vineyard sustainability and the winery profitability are put at risk, obviously. The last part of this presentation will be about berry and water. Berry development occurs over two main stages: the green growth stages after flowering and fecundation, and the ripening stages, which is starting at veraison. The onset of veraison is berry softening. The volume of the fruits is under the control of vine water and nitrogen status, berry seed number, hormones, and other parameters. Trying to understand the effect of abiotic factors as water on berry composition it's very important to differentiate pre and post-veraison. Why? Because pre-veraison, during the green growth stages, some specific compounds are elaborated or accumulated like tannin and organic acids. And to make a long story short, from veraison onwards, other compounds are accumulated. So, to make a long story short, it's important to understand the effect of abiotic factors in terms of berry composition, considering pre and post-veraison stages. This figure is showing that with irrigation you can control the volume of the fruit pre and post-veraison, and it's a way to manage the yield and obviously fruit composition and wine styles. A berry is accumulating water, but as well is losing water, very little by transpiration and potentially by water backflow. From the onset of veraison, which is berry softening, a fruit is accumulating sugar in green here and water, and this figure is showing the accumulation of sugar and water on a per berry basis. It takes around 26 to 30 days from the onset of veraison for berry sugar accumulation to reach a plateau. Then from the plateau of berry sugar accumulation, ripening is continuing, and if in theory the volume of the fruit is stable, sugar concentration per berry is stable. In most vineyards and for most varieties, from the plateau of sugar accumulation, in fact, the volume of the berry is decreasing because we think as an hypothesis that the phloem is not functioning anymore. And because the quantity of sugar per berry is stable from the plateau, and because the volume of the fruit is decreasing, the increase in sugar concentration is mainly and only due to berry water loss. So, from the plateau of berry sugar accumulation, there is no direct relation between the increase in sugar concentration expressed in Brix here and the evolution of aromas and the evolution of phenols. Berry water loss and berry shriveling can be as well explained by the programmed cell death in berries. These research have been developed by my colleagues from Adelaide University and the National Wine and Grape Industry Centre in Australia. Berry cell death occurs mainly after the plateau of sugar accumulation and at the pulp level, and this phenomena is exacerbated by higher temperatures and drought. So I guess this is something we have to keep in mind speaking about berry water loss and berry shriveling. Berry shriveling is the ultimate stage of berry water loss. This is currently a huge issue in a lot of vineyards worldwide. Berry shriveling is obviously affecting yield and wine styles. So it's time now to end this presentation. This slide is showing that water, as we already spoke about, is needed from bud break to harvest. But as well, water is needed pre-bud break and post-harvest. Pre-bud break, the soil water content needs to be refilled to prepare bud break, and post-harvest, it's important to have functional leaves to allow the carbohydrate reserves to continue to be refilled. To summarize, the relation between vineyard management, cultural practices, abiotic factors, and fruit composition, wine composition, and wine styles are complex. And then my recommendation will be whatever you do in the field or whatever you do in the winery, it's very important to assess the effect of abiotic factors, cultural practices, winemaking practices on wine styles. It's very important to do wine tasting or to do some sensory analysis. It's a great pleasure for me to introduce you my colleagues, Dr. Suzy Rogiers and Dr. Anne Pellegrino, who did help me to prepare this presentation. Thank you very much for your attention and keep safe and well.